Hello students, in this video we will be discussing about generation of SSB-SC. Now coming to the generation of SSB-SC modulation. Coming to the generation of SSB-SC, we are having three techniques for the generation of SSB. This is also once asked in the IES examination objective question. Which of the following is not the generation of SSB? And he given the four options. Now see, what are the three methods? First one is filter method. Or frequency discrimination method. What is the second method? Second method is nothing but phase discrimination method. What about the third one? Third one is nothing but a third method only. And it is also having another name, Weaver's method, ORR, VEAVRS, WEAVER, Weaver's method. This is the olden days method. Of course, now we are not using this one. So for the generation of SSB-SC means now we are using this filter method only. But in the starting initial days, designing of the filters, we are having difficulty in bringing the shortcut of frequencies. Now with the help of the mechanical filter, that is going to be possible. At that time, when the filters are not that much of developed, we are using the Weaver's method. Especially this third one is for conventional in the ESA examination. And those two, some chances of objective. Anyhow, we will discuss each and every method and what is the problems. And there is one more thing is there. SSB-SC we can use only for the transmission of voice, but for audio and video not possible. Why it is not possible, we will say. And even though coming for the demodulation, coming to the demodulation of SSB-SC, either for DSB or SSB or VSB also, only one method I told, which is nothing but a synchronous detector or coherent detector or productive demodulator. All the names will be same. For generation, what we are having? Phase discrimination method or filter method. Next, frequency discrimination method or filter. Phase discrimination method, third method or Weaver's method. Demodulation, synchronous detection. Third one is third method. This is developed by the Weavers, so also called Weaver's method. What is this third method or Weaver's method is just partial block diagram I written. I will write a full block diagram with it. This Weaver's method or third method is developed by retaining the advantages of a second one, phase shift method, which is having advantage. It can generate the SSB signal at any frequency, but as audio frequencies are having as a low range. If omega is a higher range, infinite range, then getting the phase shift for that one is not possible. So by not taking the disadvantages of AF phase shift circuit, which has to give the phase shift for a large range of frequencies, if it is a short range, it can generate. So this Weaver's method used that concept of phase shifting for a low audio frequencies, low range of audio frequencies. And this filter method, this third method is also the indirect competition to filter method. But this is not used practically. It is a very complex and costly circuit. How they developed? They developed by taking the advantages of phase shift method to generate SSB-SC signal at any frequency, as AF is having low ranges of frequencies and but not taking the disadvantages of that of AF phase shift circuit, which has AF phase shift circuit to generate a phase shift of 90 for a wide range of frequencies. I already told the drawback in the phase shift method also. Now, before going for the next explanation, let me write the complete block diagram. If you see the complete block diagram, here what we are having is 4 balanced modulators and 2 low pass filters. For the first pair of balanced modulators, students, what we are giving for the first pair of balanced modulator, we are giving the audio signal AF signal, which is cos omega mt. Are you following my point or not? Here we are giving cos omega mt, and what we are doing is here directly rather than the phase shift method, what we are doing here is we are taking a intermediate frequency or AF carrier frequency we are taking. So here the first one is AF carrier. Let's take this AF carrier is, for example, I am generating sine omega naught t. 2 factor I will take to make the calculation simple. And here what I am doing is I am giving 90-degree phase shift. Then what you will get here 2 cos omega naught t. And the same we are giving here. This is the AF carrier, and we are taking the regular carrier, which also called as a RF carrier. This is giving to the, let me write this circuit this side, and the better option will be there. Looking like good. RF carrier. Any one side make 90-degree phase shift. So from here I am generating, let's take here also 2 sine I am taking because in the above side I maintain 90-degree phase shift. So sine omega ct. Here what you will get sine omega ct. Here what you will get cos omega ct. Now both we are taking these outputs and given to the summer. Then what you will get is the SSB-SC signal. This is the complete block diagram of a third method or Weaver's method. So what we are doing, the special thing in Weaver's method is, I already told, by using the concept of a phase shift method. So here we are taking an intermediate carrier. So rather than shifting the whole frequencies of a AF range, what we are doing is, first this AF range is shifted to a intermediate level, that is AF carrier range, and this AF carrier only we are making the 90-degree phase, and this AF carrier we are keeping in the mid-range of a audio frequency range, that is fixed at some 1650 frequency, 1650 Hz. Are you getting my point? So this structure is similar to the phase shift method, but what we are feeding to the last balancer modulators are slightly different. And here what we are doing is, by taking the advantage of phase shift method, which can generate SSB at any frequencies, as making AF is a low range. So what we are doing, rather than try to shift the whole frequencies, first we are shifting to an intermediate level, by taking AF carrier. Now this we are making the 90-degree phase shift. Let me bring the expressions, then the output will be the SSB-SC signal you will get, then you will satisfy for that. So what is the intermediate range value? I already told F0 value. We are going for a 1650K. So 1650 Hz, not K. 1.65K. So first to see, for your more understanding, for clarity of understanding, let's take V1, V2. Let's take here V3, V4. And a low pass filter is allowing that lower sideband of this one or low frequency of in those what are coming here. This is also same thing, final thing. And coming to the V1 students, try to follow clearly. What is the V1 value? One input is cos omega mt, another input is 2 cos omega naught t. So I can say 2 times cos omega mt into cos omega naught t. It's like a cos A into cos B formula. Cos A into cos B formula means cos A plus B, omega naught plus omega mt plus cos A minus B. So cos omega naught minus omega mt. Are you following my point or not? It's a cos A into cos B formula applied. Now see the second balanced modulator output. Second balanced modulator output is nothing but V2. What are the inputs we are coming? Same one input cos omega mt, another one is 2 sin omega naught t. So I can say V2 is 2 cos omega mt into, what is the another one? Sin omega naught t. Generally, sin value is more because omega naught is more when compared to omega m. So you can feel as a sin A cos B. What is sin A cos B formula 2 already there? Sin A plus B. So sin omega naught plus omega mt plus sin A minus B. So sin omega naught minus omega mt. Sin A plus B plus sin A minus B. Sin A cos B formula I applied. Now, these are given to where student? These are given to low pass filters in such a manner that it is allowing the low component only we are designing. So in these two, what is the low component? This one. In these two, the low component is this one. So I can say, what is the V3 value which is coming here is nothing but a cos omega naught minus omega mt. Like what is V4 student? Sin omega naught minus omega mt. Now these are given to where next level of balanced modulator. Now let's take here the value is V5. Here what is coming is V6. And we will see that summer output. And anyhow, what is V5, sir? V5 is nothing but V3 into this one. What is a V3, sir? So 2 anyhow I am writing cos omega naught minus omega mt V3 and another one cos omega ct, the RF carrier. Next, what is V6, sir? Just I am doing a gap and writing. What is a V6, sir? One input is V3. What is V3, V4? One input is V4, sir. What is a V4? Sin omega naught minus omega mt into carrier is sin omega ct. Anyhow, 2 we taken to make the proper calculations. It is a cos B formula, sir. Of course, 2 also there. What is the cos A cos B formula, sir? Cos A cos B formula is cos A plus B plus cos A minus B. So what you will get here? Cos A plus B. A plus B means omega C plus omega naught minus omega m whole into t cos A plus B plus cos A minus B. Cos A minus B means cos 2 pi into omega c minus omega naught minus omega m t whole multiplying with t. A plus B, A minus B. Following my point. Similar here also. Sin A, 2 sin A, sin B. What is 2 sin A, sin B? Actually minus has to be there. Minus is not there means cos A minus B. Cos A minus B, that is 2 pi into A minus B means omega c minus omega naught minus omega mt. Cos A minus B minus cos A plus B. What is cos A plus B? 2 pi into omega c plus omega naught minus omega mt. Just applied cos A cos B, cos A plus B plus cos A minus B. Sin A sin B. Minus is not there. So cos A minus B minus cos A plus B. And this is adding here at the SSB-SC signal. You can exactly observe them. If you clearly observe them in their addition, this term and this term exactly same. Both will be cancelled. Then what is remaining? 1 plus 1, 2. So 1 plus 1 means 2. So 2 cos 2 pi into what is there? Omega c minus omega naught minus omega mt we are getting. Which is nothing but omega minus c means we are getting a SSB-SC for lower sideband. And making the adjustment in the summer, we can also get SSB-SC for upper sideband. This is about the Weber's method or third method in the generation of SSB-SC. Slightly complex and so practically also not used, commercially also not that much used. Got my point? Anyhow, nowadays what we are using? Filter method with mechanical filters. Similar to the phase shift but with a slight, rather than directly all AF range frequency shifting, we are using the intermediate one at 1650 and we are making it. Clear?